Installation of a petroleum coke system at Union Camp's number 2 lime kiln, located at Prattville, Alabama, is a major step for this mill and the paper industry in general. Although petroleum coke has its disadvantages, the advantages outweigh the potential problems. Petroleum coke should offer a viable source of lime kiln fuel into the future, as will be shown. Approximately in the center of the pad is an opening through which coke will be introduced into the system. The opening is approximately 9 feet by 10 foot and is covered by a grizzly which has 8-inch openings. Using the front end loader, the coke will be either pushed or dumped through the grizzly to the reclaim hopper below. The number 1 conveyor is the first of 3 long transport conveyors. This conveyor is 136 foot long and rises to a little over 36 feet. The belt is 24 inches wide and is driven at a speed of 250 feet per minute and discharges into the crusher. Just ahead of the head pulley is a magnetic separator that will pick up any pieces of steel that might be mixed in with the coke. This is to protect the crusher, which follows next. The magnet that is being utilized is a Stearns Model 25A electromagnetic cross-belt conveyor. Metallics drop down this chute for subsequent removal. Since the coke will be purchased unprocessed, we may receive pieces up to 6 inches in diameter, and a pulverizer cannot accept anything larger than 1 inch in diameter. Therefore, a crusher has been provided to ensure that no oversized material will be fed to the pulverizer. This shows a typical sample of the pre-crushed coke. The number 2 conveyor is the second of 3 long transport conveyors. The conveyor is 844 feet long and rises approximately 78 feet. The belt is 24 inches wide and is driven at a speed of 250 feet per minute. The conveyor is loaded from the crusher and discharges to number 3 conveyor. A considerable amount of attention has been given to minimizing dusting with this conveyor system. All conveyors have been provided with dust-tight covers, and all other openings have been provided with seals. In the discharge chute of number 2 conveyor, a 10-inch suction line has been provided for a dust transfer fan. This is number 3 conveyor, and it is 70 foot long and rises approximately 15 feet. The belt is 24 inches wide and is driven at 250 feet per minute. A storage silo has been provided at the hot end of number 2 lime kiln that has a capacity of 123 tons. This is slightly in excess of the requirements for 1 day when burning maximum coke. The silo is 14 foot in diameter and a straight wall height of 25 feet. Load cells have been provided so the weight of the silo and hence its contents can be determined. The weight or indication of how much coke is in the silo will be determined on a control panel.
And into their stump gravimetric feeders. As material comes on, it's weighed and conveyed down the length of the conveyor, down into our chute that goes into our rotary air valve.
Okay, tell me what you're doing there.
Okay, I'm weighing the sample. So I'm going to put the sample in the top lid.
A portable moisture analyzer is next used to determine the raw coke moisture content. First, a sample of coke is weighed in a balance. Next, carbide will be introduced into the pressure vessel so that when it mixes with the moisture, acetylene gas is formed. The pressure of this gas produces a direct reading of coke percent moisture.
mix it. Okay, I've mixed the reagent and the moisture sample together, and the gauge tells us we have 15% moisture, surface moisture.
The coke will next be dried from the 15% moisture down to 0.3% moisture as it is being ground to 90% minus 325 mesh. Coke offers several advantages for use as a lime kiln fuel. The primary advantage is cost savings when compared to natural gas and number 6 fuel oil. The high heat content of petroleum coke also adds to its attractiveness. Coke usually runs about 14,000 BTUs per pound. Shown here are the kiln's heat exchangers, where the 600° Fahrenheit drying gas is obtained for the Williams DF pulverizer. This heat is required to dry the 15% surface moisture from the coke during the grinding operation. The hot gases exit from the top of the firing end of the number 2 kiln and are conveyed through this 24-inch diameter duct past a tempering air damper. This damper allows fresh air to enter at this point if the system temperature goes too high. Both the system temperature and the volume of air are controlled by the Williams 200 series computer, which will be explained later.
The air enters by way of this 24-inch diameter pipe into our wind box. As the air comes into our wind box, it circulates around and comes through what is known to us as porthole liners, or porthole openings in the bottom of the mill. The air enters, it rises, bringing the material with it. The lighter material passes through our classifier and out through the top.
Comes out of the union behind this flexible hose.
Alright,
Travels down the stem
okay.
and into the block.
This block, put your hand on it, right there. Now there's pistons in that block that move back and forth and distribute the grease, correct?
That's correct. Grease distributes and goes out of these hoses
Okay.
and into trunnion blocks.
Trunnion block.
Air also travels around the grease hose inside this pipe, comes down through behind the flexible hose
Okay.
and through a rotary air seal unit.
Alright.
The air then travels through these red hoses
Okay.
and enters into the journal via a check valve here and purges the seal area.
And where does it exit?
The air then exits from behind these swingers
Okay.
to blow the dust away from the seal area.
Directly above the DF52 pulverizer is the spinner separator. Through the speed of this device, the coke particle size is accurately controlled to 90% minus 325 mesh.
Okay, this is our mill drive. The mill is driven by a 150 horsepower motor that has an AC variable frequency drive on it. It's connected into our spoke coupling right angle gear drive with a 9.
By varying the speed of the mill vertical shaft, the output of the pulverizer can be made to match the input of the feeder through the Williams 200 series computer.
This is a Williams System 200 computerized control system. All the instrumentation you see here is the metering devices, temperature control, manual speed pots, and handheld data terminal.
Please open the case and take that out. Hey, leave the case door open and just pull it out for you. All right.
Okay, the next thing we want to monitor will be differential pressure.
All right, while you pull up the differential pressure, we'll take a look up here as to what it's actually doing. And you're going to pull up monitoring.
It's varying between 6 inches and 6.4 inches.
All right, could you hang that back up and let's take a look at the control panel, and then we'll go under the control panel to look at the computer.
The system is set up so the first thing in sequence that you turn on will be the control power and the computer power together.
Show me the computer.
Okay, the computer is located down in the lower right-hand front corner of the control panel. The computer consists of 3 boards.
Okay, show me the boards. One there.
CPU board, analog input, and discrete I/O, and analog output. Okay,
Now, what do you got there in your hand?
this is a sample of the product coming to the burner from
You
the
put it down
pulverizer.
right next to the... Okay, put a little more out there. And would you tell, would you smell? That's what I'm looking for. Now, what is the fineness on this?
Okay, the fineness here is 88% minus 325 mesh.
Once the material is fine enough, it travels out the classifier, out the top of it, across through this 18-inch diameter pipe, travels into the exhauster. Once it reaches the exhauster, it's then picked up, transported directly up to the kiln by way of this 18-inch diameter pipe. I'm presently standing alongside the Cohen combination fuel rotary kiln burner. Burner is designed to burn a number of fuels and is presently firing petroleum coke, pulverized with a sustaining natural gas fire. The petroleum coke enters the kiln through this 18-inch pipeline, passes through the 18-inch safety shutoff line, down and into the center of the burner. Primary air for the burner is heated and is being controlled at approximately 450 degrees Fahrenheit and enters through this ductwork controlled by this damper and enters the burner around the outer circumference of the coke stream. Coke stream itself passes down along the center line of the burner and into the firing area of the rotary kiln. The burner is presently firing approximately 100 million BTU per hour, with between 80 and 85% being petroleum coke. The remainder being...
now is on the tip of the burner. What you should be able to see is a black area called the fuel plume. This is an area of unburned coke just prior to ignition. You may also be able to view streaks in the black coke plume, which are jets of natural gas that are being used to sustain the combustion of the coke. At the end of the black area or plume, ignition occurs and is extremely radiant in color, similar to an oil fire. The fire itself appears to be well defined.
We're looking at the number 2 lime kiln, and lime is producing at about a rate of 250 tons a day. The lime's approximately at the hot end 2200 degrees. The cold end temperature is about 560 degrees.
Installation of the petroleum coke system for the number 2 lime kiln is a major step for this mill and the paper industry in general. Although petroleum coke has its disadvantages, the advantages outweigh the potential problems.
Of the dry skid package for pulverizer number 3, boiler number 2. Up here, we have the discharge spout, which comes out at the bottom of the pulverizer for discharging trim metal, pyrites, things of this sort that collect in the bottom of the pulverizer. We can open this while this mill is in operation and drain off a portion of the material into a wheelbarrow. It comes down this chute through this continuous slide gate and will discharge into the wheelbarrow we see here. Here we have some hard to dry material. This is a rock here. This is a very hard piece of material here. And throughout this material that we drain out of the bottom, here we have a nut that you can see that would come out of the bottom of the pulverizer. So we can discharge the hard to dry material in here periodically.
This metal came up the conveyor. It was delivered the number 2 pulverizer. You can see here that this metal got in underneath the plow, as did this, and could have caused severe damage if not detected. This all wound up in the metal trap, was exhausted out. At this time, we weighed this up, and there is 15 pounds of metal that came out of the bottom discharge of the number 2 boiler, number 3 pulverizer. As you can see, these were nuts and bolts that were cut loose from the conveyor and then were deliberately thrown onto the elevating conveyor. And apparently this was done after it had been past the magnet. Here's, looks like a drilling bit that escaped the magnet. Perhaps it's manganese steel. But the worst thing that we can see right here is this type of bolt that made its way underneath the plow, and you can see was actually dragging through the material. Now, definite procedures should be enforced that when burning nuts and bolts along the conveyor line, they are not placed on the conveyor. Going. Okay, now I'm coming around to Bill, who is turning his. Okay, bring it around so that we can see the lubrication system. All right. Okay. Now, would you point how the air comes out of the hoses and goes down to the journals? Comes out, down there. Where does it go? Okay, it comes down into there. All right. Through that line. Okay, show me how that thing rotates. We're reading on this, currently on this gauge here, about 13 and a Now, Billy, if you walk around and open the door. And if you would now reach in and rotate the blades. And at the same time now you would point to the liner on the door. And step back.
In this area, we have the spinner separator access door. By removing each bolt, we can pivot the door open and gain access to the blades on the spinner separator and access into the gearbox. Dropping down below here, we have the access door that is located on the pulverizer cover. By opening up this door, we have complete access into the internals of the pulverizer. The journals may be removed through this door for maintenance. Located overhead, we have a beam crane where we can attach a 1-ton chain hoist and use that to remove the journal from inside of the pulverizer. We also have access through this door into the lubrication system and the air seals that are located on the inside of the unit whenever we want to go in and to check the operation of those items. To access this pulverizer to replace the underwear item, which is the bull ring, it would be necessary for us to remove half of the mill cover to do this. So what we would have to do is to come over, we would remove the bolts from this flange in this area, remove the bolts around the top of the mill bottom, remove the bolts from this half of the cover around to the opposite side here, and this cover would then come off. We would then remove the air seal line and the lubrication line from the inside, go inside the pulverizer, wash it down, and then we could cut the old bull ring out of this pulverizer. Then we would come in with a fork truck, lifting the other bull ring up over the internal ports and dropping it into place inside the pulverizer. That is how we would have to replace the bull ring in this when it becomes worn and we want to replace it. The discharge pipe goes up into the Chicago bore exhauster, goes in, turns around inside the fan, and then is discharged up to the splitter, which is located up on the upper floor. We saw this earlier. By controlling the damper, currently waiting for the operator and the wire computer to open the coal valve and bring this pulverizer to a standby condition. The operator is opening up, indicating that it is now open, and these lines are now in service and ready for air and coal to be blown to the burner. illustrated here are two of the burner pipes going up through the burners up on the upper level.